As our friends enter the Emerald City, they find a bustling town full of activity. Town members help them get all cleaned up to meet the wizard. Chemist Brian Eklov will help us explore elephant toothpaste and the science behind bath bombs. Meeting the wizard can be a little intimidating, but Tajay Haywood will show us it's just smoke with an experiment called the Genie in the Bottle.
I'm Brian. This is Julia and Adam, and they're helping me today with elephant's toothpaste. We hear there are some teeth that need to be cleaned, and this is a great way to get started. So what we have here is a little bit of hydrogen peroxide solution. It's the kind that you'd buy at the store to clean out a cut. It has some dish soap in it and a little bit of green food coloring. And in this flask here, we have some baker's yeast, like you'd use to bake bread. And so the yeast have an enzyme called peroxidase, which breaks down the hydrogen peroxide and forms oxygen and water. And with the soap that's in there, we should get some nice foam.
Is that water?
It is water. You ready?
Mm-hmm.
3, 2, 1, go.
It looks so fluffy.
So this is elephant's toothpaste. You get nice foam out of it. It's thick like shaving cream, but it tastes like soap, so don't actually use it as toothpaste. Okay, so now that we've brushed our teeth and we've gotten cleaned up with the elephant's toothpaste, we would like to talk about bath bombs. We need to, clean the rest of us, not just our teeth. So what we have here is some good old-fashioned baking soda and some citric acid. And so what we need is 1 part baking soda. I'm going to measure it into this here. And 2 parts citric acid. It's a little chunky. Let me break that up a little bit. This is all actually food grade material. Went a wee bit far.
Another chunk.
There we go, that'll do. So you can see we've got about 2 to 1 citric acid to baking soda. And so baking soda is a base, and citric acid is an acid. It says so right in the name, right? And so when we mix acids and bases together, in this case, they neutralize. But in this case, with the baking soda, with the sodium bicarbonate, it produces carbon dioxide gas. And so that's one of the reasons why it's used in baking, because it produces the gas and helps make your baked goods less dense. So the solids themselves won't do anything when we mix them. You want to stir that up pretty gently? Or do we need another bucket to put it in to mix it up? Do you know what else we can do to mix it? Watch this. You want to see a trick?
Switch it back and forth.
Yeah.
Back and forth.
Back and forth, back and forth.
Mm-hmm.
We mix those up and nothing happens. It's very boring. Nothing happens because we need something to get the 2 solids to more than sit next to each other. You want to give it a couple of stirs? Now to make a bath bomb, you can find recipes online. But basically what you need is the acid, the base, and something to hold it all together. And we're going to use a little bit of oil here as a binder. You'll find lots of things online. Look good? Mm-hmm. Okay. So let's drop a little oil in. That'll bind everything together.
Maybe add a little bit of food coloring.
If you want to add a little bit of food coloring, now's a good time to do it.
Okay, ready?
Mhm.
No?
That's good.
Green.
Green. Green's a good color for today. We're going to add a little bit more oil.
A little bit more green?
I think we've got plenty of green.
No, Dad. The bottom won't get
I think we've got plenty of green.
Yeah, huh?
Mm-hmm. And so we need one more thing to make it a bath bomb, which is when the reaction happens that everybody wants, which is the mixing of the acid and the base. So we didn't use water to combine them for a good reason, because they'd start to react. Using the oil keeps them from reacting. And so this is not going to get mixed to the point where everything is perfect today.
So would I be able to mold one?
Would you be able to mold one? Let's find
Yeah.
out. It's an experiment after all.
Da da.
Is that science music?
Dramatic science.
Dramatic science music. All right. So I think this will mold pretty well. Do you want to squeeze them together?
Put them in there.
Nice right there.
Mm-hmm. Squeeze it.
Crushionation.
Yes, crushionation.
Oops, tripped them. Like this? It's not a perfect thing, but
It's not a perfect circle,
Yeah.
but it will compress. If you had a mold that looked like a, it was spherical like a ball, then you'd get a round one. Or if it looked like a cat, it would look like a cat when you were done. And then, yes, you should be able to drop it in the water. And there you go.
Yours kind of broke apart on it. Right?
Yeah, if you were going to use a press, you'd use less oil.
can I make another?
We've got like the whole witch's brew going on here.
Yeah.
And then there's smoke.
And so when the acid and the base start to dissolve in the water, that would be your bath, that's when you get the reaction to occur.
Oh.
And so that's why you can keep
And then your water.
the mixture of the acid and the base in your bath bomb, and they only react when you add the water, which is why you have to keep them dry.
Hi, I'm Tajay Haywood. I am an analytical chemist at Perrigo. Today, we will be making a genie in a bottle. For this experiment, you will need hydrogen peroxide, tissue, string, and manganese dioxide. We will start by weighing 4 grams of the manganese dioxide into the tissue. Okay, and then once that's weighed in, we want to carefully wrap it in a nice little package. There, and that's a little extra tissue, we can just tear that off. Then we want to tie that up with the string. And grab our bottle. And before we insert the package with the manganese dioxide, we will pour in some hydrogen peroxide. So hydrogen peroxide is something you may use at home all the time, but the hydrogen peroxide we're using is 30%. So it's not safe to use for those cuts and scratches that you might have. We will carefully pour the hydrogen peroxide into the bottle. Perfect. And we will carefully put our little package of manganese dioxide into the bottle. And hold the end of the string so that way the reaction won't start until we are ready. And now it's ready. So we can rub the lamp as if we're waiting for the Genie to come out. And once we open it, he's coming out, or she's coming out. And what you see coming out of there is actually oxygen and small droplets of water that were formed when the hydrogen peroxide reacted with the manganese dioxide. So in The Wizard of Oz, Dorothy and her friends see smoke when they go to meet the Wizard of Oz, and they're frightened of it. But we just learned that the smoke was just oxygen and small, tiny droplets of water. So there's nothing to be afraid of. As always, remember to be safe, and thank you to everyone for coming out and enjoying it, and have fun at Chemistry Day.
The wizard agrees to send Dorothy home, give the Scarecrow a brain, the Tin Man a heart, and make the Cowardly Lion brave if they bring back the broom of the Wicked Witch of the West.